These are your last notes for the year. So we're going to finish out this week talking about climate change. And you probably have heard about climate change. Maybe you know some things about climate change, but it is an incredibly huge and complex topic. So these notes are just going to be a rough overview. Like we could spend an entire year talking about the science behind climate change and what scientists know and how do we know it. But we don't have time for that. We have 4 days. So this is just a rough outline of what's happening with climate change and what do you need to know about the science behind it. So first we're going to start with greenhouse effect. So the sun sends us lots of different kinds of solar radiation. It sends us visible light, it sends us infrared, it sends us ultraviolet, and all of those things come to Earth and they warm up the Earth's surface. And this is great because it makes it so that it is warm on Earth. And if you think about it, like without this warming of the Earth, when the sun isn't shining, it would be like super freezing at night. So having, trapping that sunlight here on Earth is a great thing for us, and it makes our planet kind of tolerable and a good place to live. So heat hits the Earth, and then a lot of it jumps back into space. It gets reflected back into space. It kind of looks like this. So the sun sends us a bunch of stuff, and it all comes in, and then some of it bounces back. It gets like shot back into space. But there are some molecules in the atmosphere that are called greenhouse gases, and not every gas is a greenhouse gas, but these are the ones that can absorb heat. So when that solar energy hits them, they don't just shoot it back into space, they store the heat as stored chemical energy. So greenhouse gas molecules absorb heat and then can store or scatter that heat, and that traps the heat here on Earth and keeps it just bouncing around back and forth in the atmosphere. So here, energy comes in, and you hit some of these greenhouse gases, and sometimes they just let it transfer right back into space. Sometimes they store it and pass it along. Sometimes it just bounces right back off. But there's lots of different things that can happen with the infrared radiation that comes in from the sun. But these greenhouse gases play a role in that. Three of them, not all of them, but three of them are water vapor, carbon dioxide, and methane. Nitrous oxide is also a pretty big one. The one that you hear a lot about is carbon dioxide, because when you look at these, this one is the one that we can 100% for sure say that humans are having an impact on directly. Like we are putting a ton more carbon dioxide in the air today than previous. We're not really doing that with water. We are doing that a bit with methane, although we've made some steps recently to kind of get rid of that. One of the major sources of methane is cows. When cows like burp and fart, they release methane, and that makes more greenhouse gas in the air because we like our cows and we have lots of cows and people like eating beef. And so we've made some efforts to kind of genetically engineer cows and sheep and those sort of ruminants, so that way they fart and burp less, so they make less methane. But carbon dioxide, we are far and away putting a ton of into the environment that wasn't there before. So greenhouse gases make a thermal blanket around the Earth, which is good. We think of like, oh, a thermal blanket, that's bad. But it's only bad when it goes crazy. It's great when it's normal because it traps heat on Earth and makes it so Earth is like a really nice place to live, averages like 60 to 70 degree temperatures. And when the sun goes down at night, it doesn't drop to like negative 1 million degrees because we have trapped heat. And so it's good. But as we release more greenhouse gases, then we absorb more heat and it gets hotter. And that's where we are right now. Like it's too much. We've gone to where the greenhouse effect is running away and going kind of crazy, and the Earth is getting warmer. And if you have to, you don't have to look very far in the solar system to find a planet that where the greenhouse effect has destroyed the planet, and that's Venus. Venus has tons more greenhouse gases. And so, because of that, Venus is much, much hotter than Earth. The surface temperatures of Venus are like 500 degrees. And that's because there's so many greenhouse gases in the atmosphere of Venus that it's kind of gone crazy. So greenhouse gas is a gas such as carbon dioxide and methane. It absorbs radiation from the sun and it traps the heat in the atmosphere. And then when we talk about climate, what we were talking about is a range of weather from region to region. Climate is long term. If you look outside and it's windy today, that's not your climate, that's your weather. So climate is like the patterns over decades, like a long period of time of what the kind of the weather pattern was in that region, but it takes a long time to talk about climate. Global warming, when in the 90s, this no one said climate change, everyone said global warming, and then people realized that that's kind of a bad branding because it's not just about heat, it's not just about warm. There's lots of other costs to this climate change problem. So sea level rise is a consequence of that. Hurricanes are a consequence of that. Wildfires are a consequence of that. So if we just talk about global warming, then when you have like a crazy snowstorm that can be tied to climate change as well, people are like, hey, I thought it was supposed to get warmer. But climate change just means like stuff's gonna change. Like your extremes are just more extreme. There's more snow, there's more hurricanes, there's more wildfires, there's more floods. It's just everything is intense. So we kind of dropped the global warming label. So it's a gradual increase in temperatures of the Earth's atmosphere caused by gases and pollutants. And then climate change is a change in a region's weather conditions. So that could be it gets colder, that could be it gets hotter. So just saying global warming doesn't keep track of all the other things that are happening as well. That's why we say climate change. Fossil fuels are natural fuels formed from the remains of living organisms. So this is petroleum, which is crude oil or gas, oil, coal, and natural gas, which is methane. So if you like have a gas stove in your home, you use that methane. But where these oils come from, where this gas comes from, where the gasoline for your car comes from, is like 400 million years ago. Some plants and animals on Earth died in low oxygen conditions, like maybe in the bottom of a swamp. And they didn't decompose fully, and they left behind their carbon chains instead of breaking them down into smaller carbon pieces. And so because they didn't decompose, that's what this stuff is. So it's oil, coal, and natural gas is their carbon remains from these organisms that died. So you're literally fueling your car on dead plants and animals from 400 million years ago. Now, sometimes we say like, oh, that's why they're called fossil fuels, because like from dead things, but sometimes people say, oh, they're from dinosaurs. But 400 million years ago is long before the dinosaurs. So chances are you're not like running your car on a dinosaur or like a T-Rex, because we don't have a lot of fossil fuels from that area. But we're talking about the small plants and animals that did live on Earth like a really long time ago. And so their bodies, when they didn't decompose, they became fossil fuels. And that's fine if they stay on the ground. The problem is that we don't leave them in the ground. We dig them up and then we release that carbon from 400 million years ago into our current atmosphere. Sea levels are rising. They've gone up 17 centimeters in the last 100 years. That doesn't sound like a lot, but that's double what it's done before. And so the more sea level goes up, the more coastline we're going to lose as lands get flooded, then the ocean kind of takes them back. And that's going to be a problem since a lot of people in very expensive homes live somewhere near the coast. A lot of people are going to lose their houses over the next 50 years or 100 years. And the reason why that is ice. Size and thickness of sea ice has decreased. Sea ice is not as big of a problem. So when you think about like you have a glass of water and has some ice cubes floating on top, that ice is already displacing volume, and so when it melts, it's not really going to fill up your cup. But if you were holding an ice cube like above your cup and it was in your hand and it was kind of dripping into the water, as that ice cube melts, it's going to fill up the cup, and it will go up. So that's land ice. And so that is the ice in Greenland. That's the ice in Antarctica. That ice isn't in the water right now. That ice isn't in the ocean. That ice is trapped on land. And so when it melts, it's going to lift the ocean. So sea ice, the stuff that's already in the ocean, is not that big of a deal, but land ice is the problem, and the land ice sheets are melting too. Here is a picture of what's called the McCarty Glacier in Alaska. So this is current. this is 1909. So you can see there's a bit of a difference there. This huge glacier has now melted, and that's what's contributing to the rise in the ocean level. Global temperatures will go up, so the number of record high temperatures has increased. You'll hear all the time like, oh, last year was the hottest year on record, and last year was the hottest year on record, and so on and so forth. And it just keeps getting hotter. So if we look at this graph here, this is global temperatures from 1880 through 2020. And so if you just look for like at the line, you'll see, well, it just always goes up and down, up and down, up and down, up and down. And it does because wherever this was measured, there's a cold time of the year and a warm time of the year, and the cold, warm, cold, warm. So that's why you see this like little zigzag line. That's why it's not a straight line. But if you look for the trend, the overall trend is since 1920, we can very clearly see an increase here. It's just continuing to rise. So overall, the temperature on Earth does continue to get warmer. It is getting hotter on Earth. Hurricanes are getting more intense, those in the Atlantic. And the reason why is hurricanes are fueled by warm water, and the oceans are getting warmer. So you're getting stronger hurricanes because they move faster and they suck up more water because they're hotter. So it's when hot water meets cold water, that's where you get a hurricane. So if you have more hot water, you get bigger hurricanes, and they're more intense and they're more damaging to America. Changes in precipitation patterns. So temperatures are going up, then that's going to evaporate more water and that's going to bring more rain or snow, and it doesn't spread evenly. So it may be a drought in one place and like super rainy in another place. Some areas get more rain, some areas get less. That's just a consequence of climate change, and precipitation patterns change as well, which is why it might snow more often in like the Midwest of America. And people might say, hey, it's colder, so it's not climate change, but when it's snowing in one place, it might be much, much drier in the other. So you kind of have to look at the entire world and the patterns that you see there. Another thing is ocean acidification. As you put more carbon dioxide in the air, the ocean is the #1 absorber of carbon dioxide. The ocean is what we call a carbon sink. The ocean sucks up carbon from the air, and that's helped us out. It's helped us from the temperatures being even worse without the ocean. And so the ocean is sucking in more carbon dioxide. Well, what that means is as carbon dioxide dissolves in water, it forms carbonic acid. So carbon dioxide in water makes carbonic acid. And what this means is the ocean is getting more acidic. And it's gone up 30% since the Industrial Revolution in the 1800s. And so the ocean is just taking in more and more carbon dioxide and becoming more and more acidic. And animals that have shells, we're doing a lab like this in person this week, their shells are dissolving. When seashells react with acid, the shells dissolve. And so a lot of people are seeing their seashell farms, like with mussels, where they're harvesting mussels for food, they're seeing the shells of their mussels get thinner and thinner and thinner as the ocean gets more acidic. Carbon dioxide is a minor, meaning it is not a whole lot of carbon dioxide. It's like 0.04% of our air is carbon dioxide. So it's actually a very small percent of our air is carbon dioxide. But it's very important, and it's really good at holding heat. So putting more carbon dioxide, even though it's such a small amount of the atmosphere, leads to pretty good changes in heat on Earth. And humans have increased the atmospheric carbon dioxide concentration by more than a third. So it's a third larger than it was in the 17 and 1800s. So it is significant, and it's happening quickly. That's the other problem, is the speed at which we've been putting carbon dioxide in the atmosphere. It doesn't really give the planet a whole lot of time to like respond to that. Here is Mauna Loa. Mauna Loa is the largest volcano in the world. It is in Hawaii, and they've been measuring carbon dioxide there for a really long time. So starting back here before 1960, you can see the red line. It goes up, down, up, down, up, down, up, down. And this is kind of cool because what makes it go up and down every year is winter and summer. So in the summer, plants have their leaves and they do photosynthesis and they suck carbon dioxide out of the atmosphere. So it goes down in the summer. And then the winter rolls around in that same year, and a lot of plants lose their leaves because it's too cold to keep them and there's not enough sunlight. So they'll drop their leaves. And so then our carbon dioxide goes up because the plants aren't doing photosynthesis. And then they come back in the spring and it goes away in the winter, and then it comes back in the spring and it goes away in the winter. And so you'll see up, down, up, down, up, down. And it's kind of like the earth is just taking a big breathe in during the spring and summer, and it breathes out during the winter. So that's why you have this kind of jiggle. Then you can see the trend though, trend line going way up. And this stops in 2010. And if we continued it, we're well above the 400 parts per million. So this is our contribution. And it's kind of undeniable evidence that we are putting more carbon dioxide into the atmosphere. So it says, what pattern do you see in the CO2 level? This is in your notes. And so this would be an acceptable answer. You could write CO2 levels has steadily risen from 315 parts per million to almost 400 parts per million between 1960 and 2015. All right, then you have this pie chart in your notes. So what is this showing us? And this is the greenhouse gas emissions in the United States in 2016. So who puts out greenhouse gases? And they are transportation, so that's cars, trains, buses, and electricity, like our electric lights. And so a lot of our electricity comes from coal, it comes from burning oil, it comes from burning natural gas. A large portion of our electricity still comes from fossil fuels. So even if you get an electric car, you're still running your electric car on fossil fuels because the electricity that goes to your house, most of that still comes from fossil fuels. Now we're trying to move away from that, and we're trying to move towards solar, and we're trying to move towards wind. But currently the requirements of California are only like that you have to be at 20% renewable. So that means that 80% of our electricity is still coming from fossil fuels. And then 22% just industry, like the stuff we make. You have just houses is only 11%, like where we live. And then agriculture is 9%. So transportation and electricity are the big ones there. So what are the 3 sectors most responsible? Transportation, electricity, and industry. So you'd write that in your notes. Fossil fuels were formed millions of years ago, like I said, of the remains of dead plants and animals that were buried under dirt and rock, and heat from inside the earth and pressure from the dirt and rock changed the fossils into oil, natural gas, and coal. And by oil, we mean crude oil. That's what becomes gasoline. It took millions of years to make fossil fuels. We call them non-renewable. So if something takes a long time to replenish, it's non-renewable. And so gasoline is non-renewable. It's going to take too long to get it back, to remake it. And so that's a non-renewable fuel. You can't just like make it again. Fossil fuels are formed during the time of dinosaurs. Well, it's even before the time of dinosaurs. Renewable energy is from resources that are naturally replenished, like solar and wind. So if something comes back quickly, like the sun is always shining, that's a renewable resource. Wind power is a renewable resource. Hydrothermal, geothermal, those are renewable resources. So using renewable energy will reduce the amount of greenhouse gases that are released. So solar doesn't make carbon dioxide. Wind energy doesn't make carbon dioxide. And the things that don't make carbon dioxide, those are the things that we should move towards because carbon dioxide is the problem. So what are some things that we're doing that are increasing the amount of carbon in the atmosphere? So transportation. We use fossil fuels for planes, cars, trucks, trains, ships, and those all emit greenhouse gases when we burn them, and we need to move away from that. We need to find another way to drive and move around, and it can't be on fossil fuels because they're causing this problem. So we need to move away from that. And there are solutions to that. It's not like, oh, we'll never fly a plane again. We just need to find a different fuel source. Cement. So cement is mixed with gravel, sand, and water to make concrete, and the concrete is used in buildings such as schools and hospitals and to make roads. And there's a chemical reaction that you use to make cement, and that actually creates a lot of carbon dioxide. So every time you see concrete, that created a lot of carbon dioxide when it was created. Industry. So factories burn fossil fuels, they release greenhouse gases, and that is a major source, not the most numerous source, but it is a major source of greenhouse gases from our factories. And electricity. So fossil fuels are used to create much of our electricity. Still, today, we still get the majority of our electricity from fossil fuels, and this is something that we need to move away from quickly. Lots of people are thinking about what's the answer going to be, but it's going to be a combination. We're going to have wind, we're going to have solar, we're going to have geothermal, we're going to have hydroelectric. We're going to have nuclear as well. If we're going to make enough electricity for all of Americans to always have electricity, then we need to move to all of these other kinds of resources and away from fossil fuels. Agriculture is an important industry that makes food. So greenhouse gases are emitted from cows when they fart, like I said, and burp. And so also from fertilizer. So you get nitrous oxide. That's what causes a lot of our pollution. Nitrous oxide in the atmosphere. If you look up in the summer, you'll notice that like the sky kind of looks dirty. It looks brown. That's nitrous oxide pollution. And nitrous oxide pollution is a greenhouse gas. And so it's up there making that ucky, disgusting brown layer and also heating up and trapping heat right above the Imperial Valley. So you can see that there in the summer. Deforestation is when trees are cut down. So there's less plants because we're cutting down the trees. And so if there's less plants, then there's less photosynthesis. And if there's less photosynthesis, then there's more carbon dioxide in the air. And that's a bad thing. So we think of trees as that do photosynthesis, but the majority of the photosynthesis that's done on Earth, and so the majority of the carbon dioxide usage, is in the ocean with algae and phytoplankton who are doing photosynthesis. So like 1 out of every 5 of your breaths that you take is solely from the ocean. The ocean provides us with oxygen and takes carbon dioxide out of the air. But like all things, we are damaging the ocean with acidification, making the ocean more acidic, and also making the ocean hot. And when we make the ocean hot, it doesn't hold the same life. And so it's going to do less of this photosynthesis process. So, natural processes also influence climate change. It's not just humans, although we are a big part of the problem. So, respiration is a natural process, and so animals, including you, release carbon dioxide when you breathe. That's a very small portion of the carbon dioxide in the atmosphere, but it's there. Volcanoes release a lot of carbon dioxide when they erupt, and that's because carbon dioxide is trapped in that magma and lava, and it comes out of volcanoes. And that can release these greenhouse gases. But also an interesting thing about volcanoes is when they do erupt, they emit a lot of particulate matter, like little tiny microscopic rocks, into the air. And actually what happens is the year after a volcano erupts, it gets colder because those little microscopic particles in the air reflect heat back into space, and it actually makes it cooler. This is kind of what happened to the dinosaurs. The asteroid that hit Earth down by Mexico like reflected a bunch of like dirt into the air, and it made the earth cooler. And because the earth was cooler and the sun was blocked out, there was less photosynthesis, so fewer plants, and also dinosaurs don't do so well when it's cold. And so that's what killed off a lot of the dinosaurs. It wasn't that a meteor landed on their heads, it was that it changed the earth. So volcanoes, although they do release a lot of carbon dioxide, they kind of counteract that by making the earth cooler with all those little tiny particles that they release into the air. Decomposition, so when stuff decays, it releases methane, and that's a greenhouse gas. So if you're a virtual student, you're going to watch a video about permafrost. Permafrost is frozen ground. So when that ground melts, the bacteria in the soil start eating the soil that was frozen. And so now that's more of a chance for the bacteria to decay that soil, and then more of a chance for methane. So as the ground melts, that's going to be a huge source of greenhouse gases, and that's going to make global warming go even faster. Solar radiation, so the sun itself has quiet years and active years, and it sends us more solar radiation some days and less solar radiation other days, and it has like active years. It has a cycle. And so that can contribute to temperature on Earth, and weather on Earth is how crazy is the sun. And if the sun is kind of crazy, we'll get more solar energy and more solar radiation at that time.